Mamta. Hello, Mamta. Can you hear me?
Yeah, I can. Hello.
Hi, Mamta. So, how are you?
Yeah, I'm doing good. Thank you.
Great. So, really excited having you as the speaker for Cloud Community Days. Uh,
Same.
so, uh, it would be great if you could go ahead, introduce
Yeah.
yourself,
Let me
and
share
just
my
give a brief. Yes.
yeah. Just let me know when you guys can see my screen. Yeah. Okay, then hi. Good morning, everyone. Hoping everyone is having a great sessions from last 2 days. And yeah, today I attended Murugan sessions and then Aaron sessions. It's all more of Azure DevOps, I felt, and that's because Azure DevOps is pretty famous. So I'm also trying to cover a bit of Azure DevOps and trying to show a deployment in AKS, which is Azure Kubernetes Service. So let me start with my introduction first. My name is Mamta. I have founded a company recently in the month of Jan called as Tech Scalable. We work on cloud technologies, doing consulting and training. So I come with around 14 plus years of IT experience, and I'm certified in all the public clouds. And my passion is DevOps and Kubernetes these days. So I love doing a lot of things on Kubernetes. That's the reason we would be talking about a lot of Kubernetes and DevOps today. Hope you people like the session. So let's start with it. So today we would be talking about microservices-based architectural applications which can be deployed using Azure DevOps to AKS. And these are two of the basic tools which are being provided by any of the cloud providers. But end of the session, we would see why Azure DevOps is pretty famous and what are the benefits of having Azure DevOps. So let's start with the session. Today's agenda would be we would have our AKS cluster up. We would be setting up a 2-node cluster. We would have a private container registry, which is be Azure's private container registry. And in that, we would be pushing the images, which we do build by using the Docker. And we would be setting up our Azure SQL Server. So here I want to show how an application, when it gets distributed across AKS plus a backend SQL database as well. And your Kubernetes seamlessly talks to any type of backend databases, whether it is running in Azure Kubernetes service or it is running as any other managed service as well. We would be discussing how to have that Azure repos to do our control for the code version controlling. And we would be using Azure Pipeline for continuous integration and build. I saw in Murugan sessions and Aaron session, we have covered a bit of it. So I'll just quickly run through that and try to focus more on AKS in this session. With the Azure pipeline, which is the release pipeline, we would deploy the code to AKS. And let's first understand how we would be building our infrastructure. A lot of ways are there to build the infrastructure. We can build it in an automated fashion as well. But here I wanted to show the ease with which you can deploy using your Azure command line. So with AZ command line, we can deploy using this. So I'll just try and break this because I've already bought up the infrastructure because it would take some amount of time. So I have already deployed, but I'll just explain you the command so that when you go back and try doing it, you understand what parameter needs to be passed at what point in time. So to deploy a AKS cluster, you say AZ, which is for the Azure command line tool. AKS is the resource name and action is the create. You say it as verb or action. And you're specifying in which resource group you want to create this particular resource, what would be the name of the resource, and you're enabling some add-on things. You can have a dashboard, you can have monitoring and builds, and a lot of other stuffs as well. You can use multiple other features provided by Azure itself to club along with AKS and work together. You can provide which version of Kubernetes you can want to and go with, and you're generating an SSH keys so that those keys would be used for setting up your credentials for the cluster, and you specify the region in which you would like to spin up your cluster. So I have spin up my cluster in Southeast Asia region, and I've given a unique name called as KHS demo. Let me quickly show you that. So this is my Azure portal. Hope so the font size is good. And this is the Kubernetes service which I have bought up. And let me take you through this. So in this, if you see, there are a lot of things. If you want to do a lot of stuffs like upgrading, scaling, and all that, you can do it from here itself. I had started with a 1-node cluster, and now I've gone to 2-node. It's pretty easy. You can click on this, you can say scale, and that would scale up. You just need to scroll this bar, and you can see how many nodes in the cluster you need. And you can just say apply. Obviously, that will take amount of time, because when it is bringing up a new virtual machine at the backend, it is installing the Kubernetes worker nodes, kubelet, Docker, and all that stuff, and making it ready for joining in inside the cluster with the master and the 2 worker nodes we already have. So we can go and check in the command line as well. So I'll quickly go to the command line. At this point in time, you will see just 2 nodes, but we would come back to this and we would do kubectl get nodes, and we would find in some time we would have the 3rd node up. So if you see, kubectl is the command line tool to talk to Kubernetes cluster. Once you have set your AZ command line tool, you can just set the subscription in which you have bought up this cluster, and you can right away go and fire these commands after that. So kubectl is the command line tool, get is the verb or the action I want to perform. And after that, it's all the resource type. I want to get how many nodes are there. So I'm just listing the nodes over here. And I've picked up version 1.15. The next set of resource which we would be creating would be the Azure Container Service registry. So in that, we would say Azure ACR create, which is the Azure Container Registry create. We are specifying the resource group in which you want to create. You're giving a unique name for your container registry, and you're specifying the location. So with that, your Azure Container Registry will come up. Let me quickly take you to my Azure Container Registry. In case you didn't find it here, because I have recently used, you would find it here. It's pretty easy. You can type in few words like container, and you would find few, in the beginning itself, it would be there in the first group of options in the drop-down. So this is the container registry. And as everyone knows, we have registries for saving our code. Same way we have registries for uploading our Docker images or any type of container images, wherein we can push those, and it works very similar to tools like Git or Bitbucket, where it uploads the Delta, downloads the Delta type. So here, if you see, I have the repository section. So registry is the place like a server. I'm getting a space in Azure, and I'm saying that that is my name for that particular registry. So I would get a unique name there. You have to create a unique name. And repository is the package. And in that package, I can have several versions. So since morning, I tried just testing, because as we saw a few times, demo don't work as expected. So I was a bit cautious, and I was trying it continuously. I've tried pushing so many versions of the image, and the latest one is always tagged latest. It's as soon as we push the image, it would be tagged as latest. So this is the Azure Container Registry, and I would like to show the unique name which we have, and this is the unique name of the server. So this is the server to which you would be pushing your Docker containers image. So let's go back and then see what else we have to spin. Because my Azure Kubernetes service got to push or pull images. In this case, we would be pulling the image from Azure Container Registry. AKS has to have authority for that, and that is the reason we are assigning role to it, and we are creating an assignee. We are saying that AKS is the assignee, and we are assigning a role of ACR pull, which is Azure Container Registry pull, and we are saying the scope is ACR. So this is also on the Azure level. I am just creating service principal. So how we have users authenticating via keys or passwords, same way when services communicate, they communicate via something called a service principal. And those who would be from the Kubernetes world, it's called as service account. So this is for inter-service communication. So you're authorizing AKS to pull image from ACR at this point in time. So once that is done, because we are deploying our backend database in SQL, so from this short and sweet set of commands, I can create the server and I can create the database as well. So let's break that and let's see what we are exactly executing. SQL server create, very simple. The region in which you want to create, the group, or the resource group mentioned, the name for the server, the user and the password, the admin user password, you can give it over here. Sorry for that. And this is the db create command, using which in this particular server, which you have created in the above command, you would be creating a database. And here you specify the database name. So once these infrastructures are up, let's see who gets up this infrastructure. So in our office environment or in our project environment, we would have a person who would be having the access to the Azure account, would spin up our Azure cluster for AKS cluster for us of Kubernetes, would spin up the SQL server, would create the container registry, and then he or she, or maybe some other person not from the infra team, would set up the repository from where people can push the code to, and then we would have the pipeline created. There should be two set of pipelines. So pipeline word is a bit confusing. It does pipeline does the build, and pipelines release part does the release. So you have the build pipeline, and then you would be having the release pipeline. So this part is the infra part and bringing up the complete Git, or like how we have a Git synonym for Azure DevOps, we have something called as Azure repos that is there, and the pipeline setup. So we saw the ACR, the SQL Server, and the AKS. We have not seen the Git. So let me take you quickly to my Azure DevOps portal. And this is the place. I've created a project over here. It's pretty simple to create a project. You would have an organization over here, and you can create several projects. I've created a project. You can see there's a quick button over here. You can add and create projects, and you can push your code to that. So like in Murugan's case, in his demo, the code was residing in Git, but I'm using Azure repos, and this is the place where my code is residing. So this is the repos part, and this is the pipeline part in which I have built up my build pipeline and the release pipeline both in place. And I've done the deployment as well, but I'll quickly run through the code file. When we are saying we are deploying it, we have the code with which we have to prepare the image. That would be the first section. And second, there should be a set of instructions using which the Azure Kubernetes service would go ahead and deploy this code as a container in Azure Kubernetes cluster. So for building up the images, as usual, we have the Docker compose file. We would do the build command and we'll prepare the image. And these things would be done in the pipeline section. And this would be the file which would be used by the build pipeline. Once the code is built, so code build remains the same, right? The way the code is built, depending on what type of language you have picked up, you would be picking that type of build operations. Plus, for the building of image out of the code, you are using the Docker compose file. And let me take you quickly to the build pipeline so that we understand what exactly we are doing in it. I have tried to keep a lot of environment variables as not static. So I've kept the SQL Server's ID as a variable. I've kept Docker container images as a variable. So I've kept a lot of things which are as a variable, and I'll show you how you can define variables over here. So here you can see a set of tasks defined. A lot of options are given over here, and there are a set of actions which these tasks would be doing. And in the last few sessions, you saw that in case we want any of the servers to build an image. Like, for example, if I am not using Azure DevOps and I want to build a Docker image, I would need a machine with which I can do the build, and I can create a Docker image out of it, right? So I should have a machine on which I would deploy Docker, plus I should have a machine on which I can do my build for my code as well. So here we would be taking resources, that means the servers from Microsoft hosted agent. And it's pretty easy, as in when you need the machine, you just request for it. And if it is granted, you have it. So let's focus on these services, these tasks, the run service, the build, and the push. So run service prepares a suitable environment for pulling required images, such as we are using ASP.NET core things. So it would be picking that base image, it would be restoring packages, all those things is being set in this particular task. Then you have the build section where you would be building the Docker image. So this is the place where it picks up the Docker file, Docker Compose file, which I had shown you few minutes back. And using this, it's saying that this is my registry location and this is the subscription. So you come from top to down. Here it's a container registry type. This is the subscription. And then this is the container registry to which you would be pushing the image. And you would be building image using this Docker Compose file. And
hey, Mamta, can I interrupt for a second?
Yep.
Yeah, so a lot of people are saying that the font is not, clearly visible. So would you mind increasing your screen size?
Does it look fine
great.
now? Okay.
Yep, this is great. Yeah, carry on.
Yeah, sorry for that. In case you guys have missed anything, I was just covering the run section in which I showed that you can specify what would be the type. I'm saying I would be using a container registry, which is Azure Container Registry. And once you choose the proper subscription, you should need to have a service connection built up in the project setting for this. And once you have connection with your subscription, this would come in a drop down itself. So you can see this is the registry and this is the compose file with which you would be building your image. So a few things you are setting up in the environment variable, then you are building, and then the final one is the push. In this, you would be pushing where to push, it's being sent, and it says what would be the environment variable. And when you're building, how would you tag? You are tagging the images over here, and you're saying include latest tag. So each time I build, it gets a number. You would have seen in my Azure Container Registry, it was showing up. There are few numbers in the repository. So if you quickly go here, I would like to show you that there were a set of image versions which was being uploaded, and it keeps on increasing. But to pull that, it is much more easier to pull with the name latest. That's the reason we are retaining a tag called latest over here so that people can pull it in the AKS too quick. So then we are doing publishing and all that stuff over here. You are publishing the artifacts. So here you would publish two stuffs. You are publishing the main artifact of the code, plus you would be copying a set of files. And this is the place where you're saying this also would be the part of the package, because this also has to go along with the code. And then only AKS cluster can pick this and spin up your resources in AKS cluster. So let's quickly go back to our repository and see this particular file and what is the content and what we intend to deploy in our AKS cluster. Hope the font is fine. This is the version in which this kind was introduced, the deployment kind. So Azure or any Kubernetes, these are standard Kubernetes stuffs, right? Once your Kubernetes cluster is up, whether it's in AWS, Azure, on-prem, name any cloud provider, once the cluster is up, you can run with all kubectl commands and you can manage the cluster as the way it works in any other cloud provider. So it's pretty simple. So this is a kind of resource we are trying to create. And what exactly is a deployment? Deployment is a type of resource which helps us manage replicas of an application. So I can do auto-hailing, auto-scaling, and all that stuff with the help of deployment. In case deployment is a controller which would help us maintain desired number of replicas at any point in time. So if I say I want to run one replica of this, my MHC back is the name of the application, And here, if you see, it is just labeling those resources so that it can be worked on the Kubernetes cluster. And from here, the pod section starts. So this is the label for the pod, and in the spec section, it is the container, and inside that, you are just pulling Redis image, and this is the container port. This image I'm not pulling from the container registry. I'm just pulling this image from a open source registry like hub.docker.com. Okay, and in Kubernetes, as in when you're deploying an application, because it's getting spinned as a container, and container don't have a persistent IP address, we would be wrapping it up with one more component called a service. And this is not a process that it will get killed and it will lose its IP address. Rather, it's like an entry, and it would retain itself till the time you go ahead and delete it. So here, services can be of several types. You can expose your application only within the cluster. And because this is a backend type of application and you just want to have it within the cluster exposure, that's the reason you have mentioned the type as cluster IP. So with this, what would happen? Kubernetes would expose this application only within the cluster, and you can't reach this application outside the cluster. You can specify the port number with which you want to get in connect with this application, and this is the selector for any of the labels. So because in the world of containers, you can't retain the IP addresses, labels and selectors play a very important role. You can identify an application, or you can identify any sort of resources, I would say, with the help of labels. Okay, and whenever you want to select a particular label, you say the selector part. So let's see, we would be deploying two applications, the front end and the back end. That was the back end part. And this is the front end controller monitoring the application which is being deployed. And it will make sure that every point in time, I have one replica running. And here, if you see, there are a few types in which you can roll out. You have canary type of deployment, you have deployment rolling out as blue-green deployment. You can do a lot of things with the help of the resource type deployment, okay? Let's go to the section of pod and the container with which we are more interested at this point in time. So this is the label for pod, and this is the spec section in which I'm defining my container. And this is the name of the container and image I'm giving where to pull from. And I'm saying always pull the latest image. So what would happen in ACR, even the last build was 97, that particular image is tagged with two different numbers. One is the 97 and one is latest. Even though image is one, it has two separate names, you can say, like how you have a good name and a name with which you are addressed at home. It's like that. So if you want to not change this number every now and then with the build number, you can write it as latest. And in your push time, you can say that include the tag of latest. Okay, and this particular container would be exposing port number 80. These are a few of the resource constraints which we have defined, how much of resource we would need. And this particular service, which is being used to expose the front-end type of application, because it is front-end application, and I would be exposing this outside the cluster, I'm going with a service type called as load balancer. And this is very beautiful in case of cloud and all. When we say type load balancer, AKS takes the responsibility to talk to any of the cloud providers, or the Kubernetes service takes the responsibility. In our case, AKS will talk to our Azure cloud account and spin up a load balancer in Azure. And that particular load balancer would be helping us load balance across the number of replicas which would be there. Okay, so this is type load balancer, and this is the port number. So let's quickly go back and see the release pipeline. I showed you up the build pipeline, and I will show you the release pipeline. You can click on edit anytime, and you can see the build and the release pipeline. So this is the part I'm saying here is the Artifactory, and where's the Artifactory? Once the build was done for the build pipeline, you can pour in, and it is there in the pipeline itself. And this particular thing, as soon as you trigger, you can see here, you can say enable and disable. I want to build every time there is a change, and that is the reason I have here marked it as continuous, or you can even schedule any particular scheduling can be done, build every day at 6 p.m., build every weekend at and Friday 6 p.m. types, anything like that. And these are the set of jobs and tasks which we have. Because we got to deploy two things here, our backend would be deployed, our database contents would be pushed to the Azure SQL. So there is a DB deployment happening. And then we have the complete set using which we would be deploying two container services, which would be running in Kubernetes. So here, if you see, we would be deploying that in AKS, and this is that deployment section. So this is the normal DB deployment which we have. And in case of this as well, we are using a set of Microsoft hosted agents so that we can trigger that deployment. And here also we have an agent with which we would be communicating to our AKS cluster, because Azure DevOps is there on the cloud, right? I don't have a machine from which I can run a kubectl command, or I can really push or trigger a deployment. So we pick up our Ubuntu machine, and then we go ahead and trigger this deployment. So this is also pretty same. You are just using your service connection. You are saying which subscription. And because you are deploying this to your AKS cluster here, instead of giving the ACR, that time we were intending to pull or push the images to our container registry. So in this case, we are using this resource group. Inside this resource group, we have a cluster, and there is where we are pushing. And in Kubernetes, apply is the command in case there is a delta change that would get updated. In case you're doing a fresh deployment with kubectl apply as well, you can apply that deployment for the first time. In case there are no resources, it would create them. And in case there are existing resources, whatever delta is there, that would get applied. So this is the path it would be picking up. We had seen this file just now, the mhc-aks.yaml, which had the deployment and the service definition. And this is the place it says where to pick the image from. So with this, if you trigger the build, I know the build will take a bit of time. Let me trigger the build still, so that in case it finishes, we can know that the build has finished. So this is my build pipeline. I'm just running the build pipeline. And because I have automated the build and the deployment, I can do the deployment in an automated fashion. You can quickly go here and check for the updates. In case your build has started, it has grabbed a Microsoft hosted agent, it will start doing the set of action. It is starting the first phase, and it is initializing, it is checking out the stuffs, and slowly it will run one of all the tasks and jobs which you had specified in your build pipeline. Same way, once the build pipeline is done, it has pushed the image to your ACR, it would trigger the what we'll say the release pipeline. Okay, so let me quickly take you to my cluster. And to talk to the cluster, I'm using my terminal of my Mac laptop itself. And from here, you can do kubectl get all. This will give me all the resources which are running at this point in time in my Kubernetes cluster. And if you see, I have two things running. These are the nodes, and these are the pods which are running. One is the front-end pod and one is the back-end pod. And I have two services, one of type cluster IP, the other type load balancer. This IP address is not resolvable outside, only within the cluster you can resolve it. And it doesn't have an external IP associated with this. And for the load balancer type, you get a IP address, and with this you can reach the application. And if you see, this deployment already says how much is ready, how many is expected, and all that stuff, right? Instead of getting that deployed, because that will take a bit of time, I'll show you how you can scale from here itself. We want to scale our number of replicas in the deployment. So you can give the name of the deployment which you want to scale, like the name of the deployment is this, and you can give -- replicas, and you can say equals to 5, for example. What would happen? It would quickly spin up 5 new containers wrapped up with a pod for you so that Kubernetes can manage. Let me show you the pods. You can do kubectl get pods to list the pods in the cluster, and you can see already 2 are in running state. We were running with 1 and I scaled to 5. So 3 of them are in running state and 2 have just started creating. And if you want to do a watch on this command, you can do with -w. And there is an error. Few of the images are proper and few of the images are not reflecting correctly. We can debug that, but that would be an image issue, I think. I can quickly show you where are these pods placed with -o white command, and you can quickly go and check, and you would see normally it gets distributed. Our third node is also in action. It's 0, 2, and 3, the node numbers, and it is almost equally distributed across them. And there are few errors in this. We can obviously go and check back what is the issue. So how do? You can do a kubectl get events. Normally, we don't expect this to happen in real-time live demos, but you can't help. There is some issue with that, and it's giving an error. So let's go for it, and let's look why it has failed. It says object has been modified, and it doesn't have the latest version. I think we have run the build and those things parallelly, and we are doing the deployment as well. So that's the reason few of the things have worked fine and few things have not. So let's see this kubectl get pods. I'll quickly scale down as well. And this is the way in which I'm scaling up or scaling down, and that's a manual scaling, right? You can say, Mamta, what's the fun about this? If someone has to really run a command and scale it, how helpful it is. Agreed, it's not that helpful, but in case you want to have that also in place, there is a component or a type of resource in Kubernetes called as horizontal pod autoscaler, and you can implement that and make the deployment much more intelligent to scale depending on the CPU or the memory resources. So this was the demo part which I wanted to show. So here we have done. We have checked in a piece of code, and that went to the repository, and repository triggered the build pipeline, and Docker image was created, and Docker image was pushed in my Azure container registry. And then we triggered a release pipeline with the new set of artifacts and the images, and we pushed that, and this was the container in continuous integration phase. And once we are having the package build, the artifact and the Docker images, you can go ahead and deploy the newer version of your SQL database, and you can also trigger your AKS deployment with the new set of AKS file which you have. And once that is done, the AKS, which is the master node, which we don't own in case of the managed services, goes ahead and pull the latest set of image. And then after it has that image, you can go ahead and create the pod. So this would be completely automated, right? The pods have automatically come up. We have not done anything to it. And we have also created a load balancer, which is there in our Azure account, but it is not residing in the cluster. It's an external load balancer, which we have created. Once we have done this, this is the CD part, and this works awesome. The CI and CD is done. So let's quickly remove that and think of the data plane part of it. If a set of users want to reach my web server, they would be routed to the load balancer using the DNS name, and that would get routed to the front-end application container. And in case my front-end application container wants to talk to the back-end application and it wants to talk to the database, all those things are pretty stitched up at this point in time, and we can see our database is serving and our website is up. So quickly, let me pick up the service IP address. So you can do a get service, and this was list all the services, and this is the IP address with which I can reach. So let me quickly go to the page and here see whether I can reach. And this is the one which I'd opened. If you see, this is the same IP address. This would take the time to load. Yeah, it's up and running. So this is the website we are hosting using our AKS cluster. This is running in container with 3-tier type of application, the front end, Redis, and the SQL backend as well. So this is what I had plans to show as a demo. In case there are any questions, I would love to pick that. Let me quickly switch to my SteamYard thing. Hope I'm on time. I was not actually taking a note how much time I've taken.
So yeah, Mamta, this was a great session, and we've got a bunch of questions in the comment
Sure.
section. So what I'll be doing